Read. View your world differently. Look at the following pictures. On the left is a couple who just got married. It appears that the groom is as tall as a giant, lifting the bride with just one hand. Is the groom really a giant? Is the miniature bride a princess right out of a fairy tale? On the right is an incredibly big hand waking up a man who seems to be sleeping. What if the hand breaks the man's arm? Aren't the photography tricks used in the pictures interesting? Look at the photo of a person collecting clouds in a jar and the photo of a car that looks just like a small toy. How were these bizarre pictures created? Nowadays, photo editing programs make it easy to create these types of pictures, but there is a much more low-tech method that produces the same amazing results, the forced perspective technique. The forced perspective technique manipulates our human perception with the use of optical illusions to make objects appear larger, smaller, farther away, or closer than they actually are. That way, you can give the impression that your photographs were taken in a completely different context. Or, you can completely change the tone, message, and symbolism of your images. Forced perspective has been extensively used not only in photography, but also in movie making. For example, the technique can be used in an action or adventure movie scene where dinosaurs are threatening the heroes. By placing a miniature model of a dinosaur close to the camera, the dinosaur may be made to look monstrously tall to the viewer, even though it is just closer to the camera. So you don't have to scream like a little kid while watching a scary movie in a packed theater. Just remember that the gigantic monster on the screen may only be a little plastic toy, and that, using forced perspective, the movie makers turned it into something frightening to the audience. There are also cases in some movies where characters need to be of varying sizes. The same technique of forced perspective may be applied. A person intended to be larger will be closer to the camera, while a person meant to be smaller will be farther from the camera. Then, it is shot at such an angle that it appears they are next to each other and that one of them is really big and the other really small. This sounds simple until you realize that you need to build a set on which the actors can interact at the same time, while hiding the fact that they're far away from each other. As you may expect, forced perspective comes from imagination and creativity, which are, no doubt, very important abilities for success in life. There is nothing as boring as always thinking the same thing as others and having an ordinary interpretation of the world. Throughout human history, continuous development and progress have come from new ideas and novel interpretations. It is necessary to reject ordinary thoughts and try to see the world differently. You don't have to fear failure because there are new things that you can learn from this approach. Why not try to take your own forced perspective photographs? Don't forget that the best shots take time to both set up and capture. In some cases, you may have to wait for one object such as the moon or sun to move into position. In other cases, you may have to move a person into just the right spot. Try different camera angles to see what looks best, but do not forget to take several photographs of each version of your shot. Several photographs in various positions will better ensure that you pull off that perfect shot. You need to give yourself time. Don't rush it. And, most importantly, use your creativity. Think outside the box. Test your brain with optical illusions.
How the visual system processes shapes, colors, sizes, etc., has been researched for decades. One way to understand more about this system is to look at how we can trick it, that is, to look at how the brain reacts to optical illusions. Let's give it a try with the following optical illusions. There is a trick since these are illusions, but don't try to be smarter than your brain. Just enjoy being tricked.
Question 1.
Can you put the fish in the fishbowl? Stare at the yellow stripe in the middle of the fish for about 10 to 20 seconds. Then, move your gaze to the fishbowl.
Question 2.
Have a look at the squares. Are the squares inside the blue and yellow squares all the same color?
Question 3.
Stare at the circles for a few seconds. Are the circles moving or not moving? If they are moving, are they moving fast or slow?
Question 4.
Take a look at the elephant carefully. Do you see something strange? How many legs does it have?
Answers and explanations.
Compare and contrast your answers with the ones below, and learn about what was going on in your brain while you experienced each of these illusions. 1. After image.
If you saw a different colored fish in the bowl, you experienced an after image. In your eyes, there are 3 types of color receptors that are most sensitive to either red, blue, or green. When you stare at a particular color for a long time, these receptors get tired. When you then look at a different background, the receptors that are tired do not work as well. Therefore, the information from the different color receptors is not in balance. This will create the color after images.
2. The bezeled effect.
The smaller squares inside the blue and yellow squares are all the same color. They seem different because a color is perceived differently depending on its relation to its neighboring colors. Here, blue or yellow, depending on the outer square.
3. Illusory motion.
The circles appear to be moving even though they are not. This is due to the effects of interacting color contrasts and shape position. The circles could seem to be moving slow to some people or fast to others.
4. Subjective contour.
It is tricky, isn't it? The artist drew an elephant with only legs and no feet, and then he also drew feet without legs. This resulted in the illusion that the elephant has more than 4 legs. This picture contains some subjective contours, such as the Kanitsa triangle on the right. A triangle, pointing down, can be seen in this figure even though no triangle is actually drawn. This effect is known as a subjective contour. The contour of the triangle is created by the shapes around it.